So when we want to find solutions to polynomial functions so that we can graph them by locating the roots, it can be an arduous process by using guess and check. The higher the degree of the polynomial, the more difficult it is. So one tool that we have at our disposal is polynomial long division, and then the great gift of the gods of math, synthetic division. So let's have a review of both. I'm going to start with polynomial long division, partly because this problem, you cannot use a binomial of this type for synthetic division. There can be no coefficient on the x in order to have synthetic division work. For this problem, then, we'll use long division. So I'm going to write inside of the division, I'm going to write 6x cubed plus 17x squared minus 10x plus 60. And this may not have been the best example because it didn't show something that must be done. But remember, you have to write this inside as in descending order. And representing every power of x. And what that means is, if I had not had an x squared term, I would have to write 0x squared. So you can't just leave it blank because a 0 may or may not be the coefficient. You have to actually show every power of x in descending order, putting zeros in for the powers that are non-existent in your initial function. And then we're going to divide all of this by 2x minus 5. So we're only going to worry about the first term in both polynomials, and we're going to let the rest of the polynomial in both cases just tag along for the ride. So ask yourself, just like in integer long division, how many times, or what would I have to multiply 2x by to get 6x cubed? And so that would be 3, because 3 times 2 is 6, and then x squared times x equals x cubed. Once you've done that, now I want to distribute that value into the entire binomial. So we already know 6x cubed because we did that on purpose. And then 3x squared times negative 5 is negative 15x squared. I want to subtract this whole thing from the line above. In order to do that, it's a little bit trickier with a binomial than it is with an integer. I want to change the signs of everything inside and turn it into an addition problem. Now I can just add 6x cubed minus, or add negative 6x cubed, that becomes a 0. 17 plus 15, 27, 32. And then bring everything else down. Okay, next step. Excuse me. What would I have to multiply 2x by to get 32x squared? Well, 2 times 15, it's a positive number, 2 times 16, and then x times x equals x squared. Now distribute that into the entire binomial. 16x squared, well, we know that's 32x squared because we did that on purpose. So 16 times negative 5 is 80. We know it's negative because a positive and a negative, and then x just comes along for the ride. So I'm going to subtract this, which means change all the signs inside and turn it into addition. These cancel. Negative 10 plus 80 is 70x. Bring down the 60. Last step, 2 times 35 is 70. And x times 1, we already have an x. So 35 times 2x is 70x. 35 times negative 5, are you kidding me? That's a negative, and 35 times 5 times 5 is 25, create the 2. 5 times 3 is 15, 16, 17, 175. Turn it in, or it's subtraction. Change all the signs inside, turn it into addition. This cancels, and 60 is 115. So this equals, oh, it's addition. So 175, 7 and 6, 13, 235. So the answer to this division is 3x squared plus 16x plus 35 plus 235 that still needs to be divided by 2x minus 5. So when you have a remainder, there's a portion of the problem that can be written as already divided, but if you have a remainder, that remainder has still not gone through the division process, so you have to include that as still needing to be divided by the divisor. So let's do another one of these. This time we're going to divide x cubed minus x squared minus 14x plus 4. And we want to divide that by x squared minus 5x plus 6. All right, so this time our divisor has a higher degree than last time, and we have 3 terms. So we're going to follow the same set of rules. I'm going to write x cubed. I'm going to make sure I have a 3, 2, 1, 0 power on x. So x cubed minus x squared minus 14x plus 4 divided by x squared minus 5x plus 6. And we're going to do exactly the same thing this time, where we only worry about the leading term in each case and then let the rest of the polynomial follow behind in both cases. So x squared times x equals x cubed. So x times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 6 is plus 6x. And you can sort of see here why we have to allow for every term by using zeros, because when you do your distribution, you're going to end up with an x squared at 3, 2, 1 for the powers. You're going to end up with descending powers. And so if I didn't write this in, say it was a 0, the next thing written would have been a negative 14x, and I certainly can't add or subtract. They're not like terms. So you have to leave space for each term to show up in the problem. Okay, so this is all subtraction, which means change the signs inside and make it an addition problem. First term cancels. Negative x squared plus 5x squared is 4x squared. Minus 14 minus 6 is a negative 20x, and I'm going to bring down my 4. Okay, I'm back to the leading terms. X squared times 4 equals 4x squared. 4 times negative 5x is negative 20x. Oh, this is looking good. And then 4 times 6 is plus 24. So I'm still going to have a remainder. How great would it have been if I'd ended up with a 4 here with no remainder? What would that have meant if I did? Well, it would just mean that x squared minus 5x plus 6 and x plus 4 would be the factors, right? If you factored this first polynomial, that's what you would get. But that's not what happened here, so don't think it is. We have a remainder. So this cancels. In fact, oh wait, I haven't done my minuses. I got a little carried away. Okay, so I change all the signs inside and make it an addition. So these cancel, minus 20 plus 20, these cancel. 4 minus 24 is a negative 20 remainder. So I'm going to write my answer out now as x plus 4 plus, minus 20 that still needs to be divided by the x squared minus 5x plus 6. One more example. I want to divide 2x to the 5th minus 4x to the 4th minus 3x cubed minus 6x squared minus 5x minus 8. And I want to divide this by x minus 3. Okay, so first I make sure I have all my descending orders. 5, 4, 3, 2, 1, 0 in the numerator. I'm good to go in the numerator. In the denominator, I have, oh, look at this. Oh, happy day. This is very exciting. When you have a binomial of power 1, which I have, you can use synthetic division. Now, I'm not saying you can't use synthetic division if you have a coefficient. Oh, when you have a binomial of power 1 with leading coefficient of 1, you can use synthetic division. I'm not saying you can't use synthetic division in other cases, but you have to do a trick to it first, and sometimes it's not really as easy as doing long division in the first place. So when you have synthetic division, or when you have a binomial of power 1 with a leading coefficient of 1, you can divide using synthetic division. And here's what you do. You write only the coefficient. So 2, give myself some room here, -4, -3, -6, -5, and -8. So all the coefficients on top, and then you're going to put the opposite here. So now you just go through some really fun little steps. You bring the first number down, 2. You're going to multiply 3 times 2 equals 6, and now add 2. 3 times 2 equals 6, now add 3. 3 times 3 is 9, now add 3. And 3 times 3 again is 9. Now add 4, and 3 times 4 is 12, and add is a 4. Okay, this is your remainder. We love it when we get a remainder of 0 because it means that we're dealing with factors, but we didn't. We got a remainder. Remainder, this is your x to the 0 power, x to the first power, x to the second power, x cubed, and x to the 4th power. So the answer in this case is 2x to the 4th plus 2x cubed plus 3x squared plus 3x to the first power plus 4x to the 0 power, which is just 4, plus 4 that still needs to be divided by x minus 3. That's pretty cool, I think. Let's do another example then. 4x cubed plus 3x squared minus x. This textbook doesn't appear to like to give you any empty spots. Minus x plus 8 divided by x minus 3. Okay, so synthetic division, I'm going to take, I have 3, 2, 1, 0, so I have every power on x is expressed, so I'm going to write the coefficients, 4, 3, -1, 8, and then for my binomial I'm going to write the opposite, which is 3. Okay, now I do my synthetic division, bring down the 4, 3 times 4 is 12, add, I get 15. 3 times 15 is 45, add, I get 44. 3 times 44 is, good Lord Almighty, what is that? So 3 times 40 is 120, and 3 times 4 is 12, so 132. Add, I get 140. All right, so remember when I showed you up above this whole thing where you just count backward to see what the variable should be? And really what you can do, a nice little shortcut, is you know that 140 is a remainder that still needs to be divided by x minus 3, and you know it's positive. And then 44 has an x to the first power, so you're not going to write that, and it's positive. 15 then, x to the first, x to the 0, X to the first would be 15, and it's positive, and then X squared, and it's positive. So you can actually write the answer right at the bottom of your synthetic division. So let's look at what we did. We have polynomial long division, can be written just like integer division. You want to pay attention to the first term in each polynomial and just let the rest of the polynomial come along for the ride. When you get to the end, if you're lucky enough to have a 0 for a remainder, then you know that the thing you're dividing by is an actual factor of that polynomial. If you get a remainder, it is not a factor of that polynomial, and so you have to still write the problem so that you include the remainder that still needs to be divided by whatever the divisor is. When you have a divisor that has a 1, a coefficient of 1, and the power is, or the degree is a 1, so it's a first degree binomial with a coefficient of 1, leading coefficient, then you can use synthetic division, which is our favorite thing on earth, and just go through the process of synthetic division, and then you can write your answer right at the bottom by just sliding in the values that you need.